we want to determine if these two triangles are similar. Remember our three rules. We have angle, angle, we have side, angle, side, and we have side, side, side. Since we're given all three sides on both triangles, I have to check the ratios of all of the sides. Now, I can make my life a little bit easier. I know the smallest side of PM, Q, would have to be matched up with the smallest side of JKL. So I'm going to make the fraction 6 over 8 and reduce it, which is 3 over 4. They both divide by 2. Now I'll pair up the sides that are in the middle. I have the 9 and the 12. 9 over 12. 9 over 12, both of those divide by 3. So I get 3 over 4. So those two ratios are the same. If the third pair of sides, the 12 and the 16, reduce to be 3 over 4, then these two triangles have to be similar. 4 goes into both 12 and 16, so I got 3 over 4. Since all side ratios reduce to be the same fraction, yes, these two triangles are similar because of AA. Let's do another one. In this particular example, I have a shared angle here, and I have two pairs of sides, which means that I'm trying, if these are similar, then it would have to be because of side, angle, side, because I have two pairs of sides and an included angle. So let's check our ratios. The two smaller measurements need to be paired up, so 10 and 20. 10 over 20 reduces to 1/2. And now let's pair up the 11 and the 22. Also equals 1/2. So these two triangles would be similar because of side, angle, side. Our next example, I could do several different things here. I notice that we do have a pair of vertical angles, so those two have to be congruent. So I could use side, angle, side. I could also use side, 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 because I do have all three sides of each triangle. I think I'll go for side, angle, side to see if they're the same. I have to use the included sides, or the sides that create this angle, so I can't use the 16 or the 6 or the 15. So I have 5 over 12.5, the two smaller sides. Since 12.5 is a decimal, I think I will just convert this into a fraction. So 5 divided by 12.5, I'll convert this fraction into a decimal to be 0.4. So if these two triangles are similar, then 8 over 20 should also be 0.4. 8 divided by 20 is 2 over 5, which does, in fact, give me the decimal 2.4. So these two triangles are similar because of side, angle, side. In our next example, we have two triangles inside of each other. The smaller one, AEF, is inside of the bigger triangle, ACB. Now, since they share these two angles, they have to have those angles the same because it's in both triangles. They both have angle A. And it looks like I have two pairs of sides here, so I will try to prove it using side, angle, side again. So taking the side 8 of the smaller triangle, I will compare it to the side of the big triangle, which is 8 plus 4, or 12. So I will create 8 over 12, one fraction, and reduce it. They both divide by 4, so 2 over 3. So now let's compare again. The smaller side, or the smaller triangle, over the side of the big triangle, 10 plus 5, which is 15. Both numbers divide by 5 to give me 2 over 3. So these two triangles are similar because of side, angle, side. Now comparing these two, I don't have any side measurements at all. So the only way I can prove that these two triangles are the same is to use angle, angle. I have a pair of vertical angles here, so I know that they're congruent. And these two sides, XR and WT, are marked parallel, which means that all the parallel line properties apply. I notice right away that I can create my Z shape and find alternate interior angles. Since two angles in this triangle are the same, the third angle also has to be the same. So yes, they are similar because of angle, angle. And the final example, I'm actually given some angle measures, but again, no side measures. So I would have to use angle, angle. This is a right angle and that's a right angle. These two are 44 and 47. So I need to find the third angle in each triangle to make sure that all the angles in both triangles are the same. So to figure out the missing angle here, I'll combine the 90 and the 47 together. And then subtract it from 180 to give me 43. And in the first triangle here, I will combine the 90 and the 44, and then subtract that from 180, which I found angle A to be 46, which means that these two triangles are not similar, because all of the angles are not congruent. All the angles do not have corresponding parts.